Welcome everyone to the ADLINK podcast, your gateway to the dynamic world of edge computing and beyond. I'm Jacky Lin, Vice President of ADLINK's Edge Visualization Business Unit. And today, joining us is our subject matter expert in the industrial automation field, Mr. Irfan Ali, NVIDIA's Global Head of Edge Solution Sales. Irfan has a rich 3 decades career across Schlumberger, Cisco, and now with NVIDIA. Irfan has been a driving force in accelerated computing, AI, and edge technology. Today, we are diving deep into the core of edge solutions, here to exploring challenges, opportunity, and the future they hold. Irfan, it's fantastic to have you here today, and we're eagerly anticipating your valuable insights.
Thank you for having me, Jacky. I'm happy to be here.
All right, let us dive right in. So, Irfan, with AI and industrial automation converging, we can expect to see a significant industrial growth in the next few years. So in your point of view, how does the partnership of AI and industrial automation that can enhance the efficiency and the safety?
Yeah, thanks for asking, Jacky. Yeah, you're right. Industrial automation is growing and is going to be a $18 trillion business by the year 2030. So growing quite rapidly and becoming very large. You know, the main drivers will be industrial IoT, digital twins, robotics, augmented reality, and virtual reality, where an AI will be at the center of all of that. You know, currently there is a trend to add AI in factory floors to drive use cases like, industrial inspection or supply chain logistics, et cetera. But there's also an interest in AI with functional safety, which is combining AI with control systems for use cases like worker safety and asset protection.
Got it, Irfan. So we understand the importance of increasing the efficiency of the overall industrial equipment. So you have talked about functional safety. So tell us more. In your view, what's the importance of the functional safety in the industrial automation environment?
Yeah, we think of functional safety in 3 main areas. There's reactive safety, proactive safety, and predictive safety. For reactive safety, that's the one that most people may be familiar with already. Most robotic arms and robots have embedded systems in them that in case of a robotic arm, for example, if it hits an obstruction during operation, the reactive safety functions within it will gracefully shut it down. So that's an understanding of that. On the other end, predictive safety is where you're taking all of the different sensor data back into a centralized location to do further analysis, like predictive maintenance analysis, or even creating a digital twin and simulating safety scenarios so that you can update your safety policy or posture in the manufacturing floor or industrial environment. Now, what's new is what we call proactive safety. And proactive safety, the way I would describe it is more of perception-based safety, where you have a sensor network, like a camera network or thermal sensors or other, sensors that are out in the environment that are monitoring the area. And if it detects a potential incident using AI, where you're doing some sensor fusion within that AI environment, then it may either alert or send an e-stop message via the control system. So basically, you're interfacing AI with the control system, enabling you to do certain actions. So for example, if there's a large materials being delivered in a particular area or moving in a different area, and there's people that may be potentially entering that environment, you could proactively send a message, alert or notification, or even an e-stop message, even before the reactive safety has detected that potential danger.
Got it. So Irfan, so tell us more. How is this being managed today in the industrial environment?
Yeah, so this use case, to your point, is not new, right? It's being done today, but it's pretty much done with people. So in most environments where you have a robotic arm or conveyor belt, and they notice that there is a emergency. The materials on a conveyor belt are piling up, or they're falling off, or they're not, it's not operating properly. Then typically there's an emergency stop button, or there's a way to slow down the machine, but that's all manually driven or manually operated. Let's say by a person. A person has to be involved in that, and that what that person does not have is that it does not have the visibility of the entire factory floor, is dealing with that situation as it comes. So consider also that the way in another case, you're familiar with large manufacturing floors where they have cages in which they're protecting people from getting in or getting injured, where there's a large robotic arm, like in the case of auto manufacturing floor, where there's many parts going through an environment, and there's huge robotic arms operating on that. This typically is some kind of cage that prevents people from entering during the time of operation. So that's how people are handling it today. But consider if you had a proactive stance of that functional safety, then you could potentially not need, you potentially could do the same function without the cost of a manual intervention, people intervention. So you could actually, put your labor force in the more higher value areas versus monitoring a particular environment. That AI can do that very effectively. Plus, the AI would have perception across what's happening across the entire factory floor as an AI model, for example. The example that I gave with the cages, if you were to implement a safety bubble, for example, AI-based, monitoring that entire area so that nobody can step into an area where there may be potential danger, you could potentially reclaim the real estate in that factory floor by not having the cage, build out throughout the factory floor. You may be able to add one or two more production lines, as an example.
Interesting. So, Irfan, based on what you described, to help us understanding this even into the next level, could you share some instance or success stories where you have seen NVIDIA's technology have helped minimize industrial equipment downtime, especially through this AI integration approach?
Sure, yeah, Jacky. The one example that comes to mind is, and I obviously can't share any customer names, but if you imagine a large, canning or bottling company that has many different, canning brands that is being produced there. These cans in these environments, are going by at these 30 cans per minute through this assembly line. So then, what we want to detect, what this customer wanted to detect, was damage and imperfections on the cans. So as they go from, that canning mechanism onto being, packaged and packaged to be delivered to the stores. But unfortunately, what happens is, as they go through these conveyor belts, there's many different machines that handle those cans, and those cans typically become scratched or damaged. Clearly, the company does not want to sell a dented or damaged can and send that to the store, right, for their customers. So what happens is, without a very intelligent system being able to pick these cans out in real time, they have to sort of destroy the entire batch, because they don't know how many of those cans in that batch have been damaged, because they saw one or two of them being damaged, right? So what they're trying to do with AI is to really identify exactly which cans or which series of cans are getting damaged, right? So that they don't have to destroy the entire batch. They can actually just pick out those specific ones. And the reason why they need AI is because AI can quickly adjust between different can brands, different labels. They have different labels by season. So you don't need a specific one for each can. The AI is intuitive enough and flexible enough to be able to accommodate multiple type of can covers and shapes and sizes. So that's why it's faster, and they prefer AI.
Understood. So based on what you described, I'm sure that's the application in the unmanned environment and with some sort of machine vision technology implemented.
Yeah, well, in that example that I just gave, in the unmanned and machine vision, is that yeah, they're in this instance they're relieving a lot of manual labor involved in that inspection. They're also doing cost savings based on being able to identify those cans more effectively through AI and machine vision. So that is how they would do it.
Understood. And thank you for confirming that.
Yeah.
So, Irfan, interesting story, by the way. So, do you have anything specifically around the worker safety or operator safety that you can share with us?
Yeah. I mean, in all of those, we have many examples. For worker safety, if you consider the environment of an oil rig, as an example, right? So if you imagine you're out in the typically in a very remote area around an oil rig or even in the middle of the ocean, and they are actually either drilling for holes or they're actually installing pipe or recovering oil from the ground. Remember that from my days as Schlumberger. So typically what happens in those environments is a lot of people working around very heavy machinery. So what we can do in that environment is similar to what I talked about earlier in the safety bubble. The AI models can look at those environments and be able to detect where people are standing, what machinery, where the machinery is located, and be able to control that is this person in the trajectory of a particular machinery, or as they start the procedure, like for example when they connect the two oil pipes together and then they put them down into the oil well, there's this huge clamp that comes in and starts rotating the tire, then rotating the pipes, and what happens is that there's a lot of injuries that happen in that instance. So if the AI model can detect that there's operators not standing in the right spot, don't have the hands in the right place, it will not even start the machine at that point. It will wait till the proper safety policies are followed, and then it can start.
Understood. So, Irfan, so this oil rig example that you just shared with us, is this a rule-based approach or this is strictly an AI-based approach?
Yeah, that's a great question because to your point, there are rules that they have put in place today, like there's policies, etc. There's also typically a person on that floor that is monitoring safety. Now again, you have a person that is going to have that responsibility, or there are actually sensors that they have around the area, like motion sensors or pressure sensors on the floor, where people, if they sense a person that's standing, then the machine doesn't turn on. Those are all what I consider rule-based systems. What we're talking about is effectively not needing those other components, because a pressure sensor on an oil rig, you can imagine that the life of that is not very long, right? They get damaged pretty quickly. Motion sensors also, that's another element that you have to manage and maintain and provide maintenance for. And then you have the added personnel needed for that. What AI does is that it's a little bit more flexible and has more capabilities to be able to do that effectively, and save the cost of managing all those other type of sensors by doing it from a perception based computer vision standpoint, right? And that actually allows you to do not only just that safety use case, but because it's the infrastructure is there, you can do many more. Are they wearing the right equipment? Do they have the right PPE involved based on, is there sulfuric gas that may be coming out of the well? So there's many other things that AI can do to augment the investments than the existing mechanisms that are available today.
Wow. Okay, great. So thank you again, Irfan. For sharing all this invaluable insight, and your expertise does show a lot of the what AI can help and enable this industrial automation environment applications. Truly inspiring stories. I really see a lot of impact from the AI on industrial automation operations. Well, to wrap up, I just want to know, Irvine, we thank you for your participation. We have learned a lot from you, and this has been an eye-opening journey into the convergence of AI and industrial automation. I wanted the audience to stay tuned for more upcoming engaging discussion, and we'll talk about the future of the technologies. And thank you, everyone. And Irfan, especially for you, thank you so much once again, and let's stay in touch.
Thank you, Jacky.
Bye now.